ACI is an SDN solution, or software-defined networking, and any SDN solution requires a controller. So for ACI, Cisco created the Application Policy Infrastructure Controller, or APIC. In this nugget, we're going to take a look at the different models of APIC, as well as how to size our APICs for a particular ACI environment. Before taking a look at the datasheet, it's worth looking at how the APIC fits into an ACI infrastructure. So we have our two spine switches, and we're going to draw just two leaf switches in this case, regardless of how many leaf switches we have. Each leaf switch connects to each spine switch. And the controllers are going to be down here at this layer. The controllers themselves are Cisco UCS servers, and they connect up to a pair of leaf switches. So again, this is what we call the Application Policy Infrastructure Controller, or APIC. Now we always deploy APICs in sets of at least 3, and typically it is going to be 3. Some larger environments might opt to have additional APICs. Either way, we're going to connect all 3 of them up to the pair of leaf switches. So a couple of things to keep in mind. First of all, our APICs are going to have, call them NICs, Network Interface Cards. Really, they're called the Virtual Interface Cards. That's a Cisco technology that rides in UCS servers. And so these VICs have certain interface types, and so we're going to want to keep that in mind as we spec out our APICs. Another thing to keep in mind is that our spine switches might actually support a whole lot more leaf switches than what we have drawn out here. And each leaf switch has so many node ports riding on those particular switches. As such, when we're sizing out our APICs, we need to take into account the total node ports throughout the entire environment. So let's go ahead and flip over and take a look at Cisco's datasheet for the APICs. So over here on the left, we have the APIC Appliance Product Specifications. If we click that, it'll fast forward us down the datasheet to the part that we really want to see, because this is going to explain for us what the different models are, as well as why we'd want to go with one model over the other. So we can draw a line here because all of the products down below this line are really just the clusters. It's a cluster of 3 of the APIC devices that are listed here above. And we know we're going to get 3, so let's just focus on the different types of models that we have, of which we have 4, as we can see here. And even these are split into 2. We have the 2 different mediums, an M2 and an M3, as well as the larges, the L2 and the L3. Now the 2 versus the 3 in these part numbers really represent the different generations. So the M3 and the L3 are our more modern take on the APIC, whereas the M2 and the L2 are what Cisco had originally released with ACI. So let's start with scaling. Why would we want to go with a large APIC over a medium APIC? And it comes down to the number of edge ports, what we mentioned earlier. How many node ports do we have in the environment? If we have up to 1200, then the medium series is going to be fine. In fact, if we're running on the old generation, then really we only support up to 1000 edge ports. But we see with the large models, even though it looks like the same numbers, 1000 and 1200, it's saying that it supports more than that. So we're able to go to the largest scale of ACI fabric using the large models. So picking out our APIC model really boils down to a single question. How many edge ports do we have in our environment? If we have more than 1200, we'd want the L3. If we have less than 1200 and we don't expect to scale beyond 1200 anytime soon, then we can get away with the M3. Now, there is one other thing to keep in mind with all of this, and that has to do with this little asterisk that's on the M3 and the L3. What that's saying, if we scroll down, is it's saying that these servers only support 10 and 25 gig SFP connectivity. Now why they're pointing that out is because the old series, the M2s and the L2s, these actually supported not only the 10 gig SFP, but also a 10 gig base T, meaning RJ45 connectivity. And so if we absolutely have to have 10 gig base T, then we might want to consider going with the older generation of APICs, as long as everything else is the same, as far as what features and functionality we need. But that aside, there's really no reason for us to go with an M2 or an L2 over an M3 or L3, other than, again, brownfield environments, we might already have M2s and L2s in production today. Cisco gives us 2 different sizes of APICs, and we have 2 different generations from which to choose one of those 2 sizes. The driving factor between how we want to size it is the number of ports that we have on our leaf switches in our ACI infrastructure. I hope this has been informative for you, and I'd like to thank you for viewing.